All right. So we changed P7, and we took out if you keep looking at your notes that we gave you, you have polynomials that we expect you to factor back in the day. And that's going to be a whole nother chapter. In chapter 2, we're going to solve inequality, quadratics, and polynomials, x to the thirds, and then actually go a little farther than that. So we're like, let's not overdo it now. Let's keep a little less information in PR and then tackle that when we get to it. So we've already done this. I'll tell you what this means up here, though. What this means is I'm gonna kind of show this with this. All right, so I have a less than question. An absolute value is less than, and it ends up looking like this for an answer. And we talked about this when we broke this down. I forgot what lesson it was. It's like PR5 or something, or maybe even PR3, where this was part of it. I talked to an individual and said, "Hey, what numbers work for this?" Well, of course, 0. The absolute value of 0 is less than 3. 1, 2. Because the absolute value of 2 is 2, which is still less than 3. Makes that true. Not 3 in this case. Like 2.9, anything up to 3 would also work. And that's some kind of like going over why we put certain symbolism. And then same thing the other way. Because the absolute value of negative 2.9 is still 2.9, which is still less than 3. So how do we show that everything up to 3 or negative 3 but not including? Back in the day in grade school, you'd put open circles. That means everything all the way up to 3 or negative 3 and in between, not including 3 and negative 3. Then, of course, for interval notation, you write it like this. Negative 3 to 3 looks like a coordinate, but it's not. That's what x equals, and the parentheses mean not including, just like the open circles. So let's look at this, and maybe we can take that and use that information. First of all, what I taught you is this. You must isolate the absolute value before you can set up two cases. Now I'm going to go back up to this. Of course, when you have an equation, the absolute value of what equals 3? And the answer is 3 and negative 3, so there's two cases. So what I told you was, I lost my x, sorry about that. 4 minus 2x equals two possible cases, 6, and the opposite of 6. You don't do it now. You have to get this isolated first. If you set up two cases with 4 and negative 4, you're done. It's hasta la vista. You will not get the right answer. All right, so isolate the absolute value, set the two cases. This is what I showed you how to do. Shouldn't be new. And then solve for each case. And then I'll show you how this relates to what we have up there. Negative 2x equals negative 10. And then when you divide by negative 2, you get x equals 5. Ooh, and I made a mistake. Something happened with number 4. I got to catch my mistake on number 4 for last hour. So blah, 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 blah. Okay, so what I do is I put these on a number line, and then we'll see, something that you'd have to have memorized comes up next. But this is what I taught you to do. It's an inequality now. There is a situation like this where there's a whole bunch of numbers that work. Is it in between these two, or is it like this one where we go separate? Well, we check. And what number is very simply between negative 1 and 5? 0. And we throw a 0 either back up to the original or after you added 2. It's probably easier to do that. 2 times 0 is 0. 4 minus 0 is 4. 4 less than 6. True. By the way, it's a less than sign, not equal to. So these would be open dots. And that means any number I would have picked between negative 1 and 5 work. And then any number before that should be false. Negative 2 times negative 2 is 4. 4 plus 4 is 8. The absolute value of 8 is not less than 6. And then same thing with 6. I don't know, I'm flipping where I'm putting the numbers that I'm checking. 2 times 6 is 12. 4 minus 12 is negative 8. But the absolute value of negative 8 is 8, which is not less than 6. So, yeah, you end up with a less than, what I call an in-betweener. So that's what this is kind of saying. If you can memorize that I have an absolute value is less than, then you should have an in-betweener. But I worry about you getting the correct second part. So we do have to also figure that out and know that. All right, and then for this one, I just want to put an equal to. So go ahead and make this change for this little basic thing here, but make this an equal to, because what that changes is for grade school, you would have put closed dots on that now. And I just want to see that. And that's what less than or equal to -3 would look like, or greater than or equal to 3. So that's just kind of looking at this one. And then in interval notation, it's a bit annoying because you have to write a lot. Negative infinity all the way up to -3. Bracket. Union that with bracket 3 to infinity. All right, and that's how that would look there. So what we're saying on this one is we're probably going to get that. We're probably going to get an answer that looks like this when we have a greater than on the inequality. So let's verify that. 3 minus 2x, you cannot set up two cases, 5 and -5. You must isolate by subtracting 2. No, you cannot subtract this 3. It's stuck in the absolute value. You can't do anything until you set up your two cases, but this has got to go. That is not part of the absolute value, so it's not stuck. So it must be moved. Then 3 minus 2x equals, yes, we taught you to drop the inequality. Your analysis on a number line takes care of the inequality at the end. So we drop the inequality and show the two cases like it's an equation. So zoom in on this for purposes of seeing well. Then you subtract 3. Well, this is nice. You get -2x equals 0. That means x equals 0. When I divide by -2, 0 divided by -2 is still 0. Subtract 3, and you get -2x equals -6. Then you get x equals 3. Okay, just want to make sure we're good on that. And then you go to the number line. Or if you're a memorizer and know that this was a greater than, what it's going to be is 0 will be here, and 3, oddly enough, will be here, and it'll go in opposite directions, and I'll prove that. Okay, here's 0, and it's another open dot. Just know if it was an equal to sign, we'd have a closed dot. And here's 3, and I'm going to plug in like 1 in between. And I expect to fail because I expect to the left and to the right to be correct. 3 times 1, or I'm sorry, 2 times 1 is 2. 3 minus 2 is 1. The absolute value of 1 is not greater than 3. That's a false. Go to -1. -2 times -1 is 2. 3 plus 2 is 5. Which is greater than 3. That's a true. That means I can go that way. And then 4, 2 times 4 is 8. 3 minus 8 is -5, but the absolute value of that is 5, which is greater than.
Hey, Mr.
Yes.
How do you know whether or not it's like the area in between the 2 points are shaded? Whether
Well,
like
what I was trying to show you is what the CAT teachers, I think Westberg made this. They're trying to give you a hint. If the absolute value starts as a less than, more than likely you're going to have an in-betweener. If the
okay,
absolute value is a greater than, you're going to have an opposite direction question. That's kind of the memorization. If you don't want to do that, you don't need that information. You could just do these tests. The number line test will take care of it. Okay?
okay.
All right, so I forgot to do this in interval notation over here. This is -1 to 5. There's our CAT answer, meow. And then this answer is negative infinity to 0. It's still a parenthesis because we don't have an equal to sign in that greater than. Union that with 3 to infinity. Now, I hope to gosh the same thing doesn't happen to me in this next question that did the other hour. I might have to analyze it if I do say so. But you don't know what I'm talking about. I ended up having a problem with number 4, and I'm going to try to catch what I did wrong. But, ooh, you don't have this one written down. So go ahead and scratch out those polynomial ones, and then just write this one down. And Let's see what I have here. Oh, okay, I see. I bet you these are ones where special cases occur, which would be crazy. All right, so here's how you do this one. You do set up your two cases. Just remember, if this was a number, it would be x plus 8 equals the number unchanged, but this is an expression, so it's just the expression unchanged. Or the number opposite. So how do you take the opposite of an expression? You distribute it. And this can happen, and this is something that you do need to know. All right, so just so you know. All right, and I think I think I know what ended up happening. I'm going to go ahead and subtract x. I'll stop talking about that. I freaked out last hour, and I think I was doing everything correct. It's just this is an odd, strange answer. And then we can analyze it when we look up at the beginning of it. So yes, so it's still same, opposite, right? That's it. I don't care that there's variables on the other side. This is how it works. But then I think we do have an odd scenario here. So usually you do get two answers, but usually, sometimes the usual doesn't happen, all right? So I just wanted to throw that out there as this begins. I'm going to add 5x, add 5x. I'm going to subtract 8. Subtract 8. I'm going to try to subtract. There we go. I couldn't get my brain to think about what 4 minus 8 was. Then just know that that's negative 2/3 reduced. So I'm going to go ahead and put these number line answers here. And this is where I freaked out. So hopefully when fifth hour looks, what's going to happen next can happen in these. So you got to be careful and look out and make sure that you don't just, sometimes there are unique cases. Let's just put it that way. All right. So I'm supposed to check numbers. This is just a shade less than or greater than -1 is a better way to say it, but -1's over here on the number line. So I'm going to go ahead and check that. -1 plus 8 is 7. The absolute value of 7 is 7. -1 times 5 is -5. -5 minus 4 is -9. Certainly true. 7 is greater than or equal to -9. So it is a filled in dot. And it does go forever this way. All right. And then now I have to plug in 0. That's between -2/3 and 3. Interesting. I plug in 0, I get 8. This is where I was like freaking out. What is going on? Because when I plug in 0 here, 0 times 5 is 5. 0 minus 4 is -4. This is still true. What? It's exactly opposite what I set up there. And then this is a filled in dot. Might want to check like another one, like 2. I'm freaking out here. 2 plus 8 is 10. 2 times 5 is 10. Minus 4 is 6. 10 is still greater than 6. That's still a true. What? Then when I plug in 4, let's see what happens with that. And I'll erase some of these. 4 plus 8 is 12. And then 5 times 4 is 20. 20 minus 4 is 16. There's my first false. This is wild. I think with variables, we got to throw that stuff out the door because this is definitely a strange answer. I got a false on this one. So very weird, right? So kind of throw that out the door when we have variables. Something strange could occur. So this is a very unique scenario. What we ended up with was just this one answer because of variables and how negatives times negatives equals positives work and all that with unknown scenarios. So very strange, unique answer. Yeah. So be careful when you have a absolute value with another variable here. And then this one I'm going to do just real quick, then be done with it. When you subtract, I know I didn't give you a chance to write this. When I subtract 9, this becomes -5. Let's analyze what an absolute value is. I don't care what's in here. What is minimum that this could become when I take the absolute value of it, no matter what I plug in for it? Maybe put that in the chat. What is the smallest output value you could get after you take the absolute value of something? Smallest output value. could be no smaller than what after I take the absolute value name. So the smallest output value could be 0. See, you're going to get as an output value here 0 or higher. It's impossible not to with an absolute value of an expression, no matter what I plug in. I could plug in a negative 1 million. I multiply that by 2, that's negative 2 million, minus 1, that's negative 2 million 1, but then I take the absolute value of it, which makes it 2 million and 1. I shouldn't say the and. So that's still not true. Here's what I'm getting you to understand. It is impossible for the absolute value of anything to be less than a negative. So what do you think the answer is to this question without even doing any math and doing any number line checking and solving 2 cases and all that other stuff? Okay, I'll hold that off. I think we're not ready 6 hour to be going on the chat. Next thing too, so hopefully we get that going. Yeah, this is a no solution. So whoever made these notes, I think it was Westberg. I think she made some special cases at the end that you have to be careful on. So I'm not setting up 2 cases because that's, there's no way. But if you did set up 2 cases, you would have got a false, and a false. You would have got false all the way across if you did your number line check and set up 2 cases. And it's because there is no possible way that this could actually happen. Okay? All right, we're going to cut that off and then go to something else. Hey, why don't you get another sheet of paper? Oop, I thought I went to that. Let me see. There it is. All right, and then, oh no, I better have done this right. I'm going to be so angry with myself. Oh, I think I did. Oh, yay. All right, I did. Okay, get a separate sheet of paper. I wanted to do this, and I did this first with 5th hour, and then I did the notes. We're done with the notes. And then the homework is online, and there's only 6 questions. Feel free to do whatever. The key's online, and hopefully what I covered plus looking at the key appropriately, you'll be fine. Okay, good. 35, 25, got 35 minutes or so. We'll start with these first 2. And I'm not going to go to the chat yet. I want you to do the first 2 without a calculator. And go ahead and get a separate sheet of paper. If this was in class, I would have handed this out to you and maybe had it as like a homework quiz, but then like showed you the answers, but then graded, because I think at this point we should know how to do it. But I was also worried, what's going on out there? I don't get to see a lot from you in this remote learning. It's really on your shoulders, man. You guys making sure you're ready. Not getting many people still coming from 2 to 3, so that just tells me everything's okay. All right, no calculator. No calculator. Good, we should, I feel like I'm missing somebody. Oh, we have 2 absences anyway, so. All right, I'll show you the first one, and then, yeah, I'll just say that. First of all, this is why it's no calculator. We're trying to exercise, do you know the negative exponent rule? So the negative exponent rule says that you need to flip, not the 2/3, it becomes 1 over 27 to a positive power. Just like this, x to the negative second is simply just 1 over x to the positive second. And 1 over y to the negative third is actually equal to y to the third up at the top. And when I kind of showed that, I think I might have showed, no, actually I didn't show where those rules come from. Just that hope at this point you know the negative exponent rule. But anyway, then what does this fractional exponent mean? The denominator is the index on the radical. The numerator is the power that you raise this to. So if I say do this without a calculator, I don't expect you to square 27. I expect you to cube root 27 first and then square that answer. The cube root of 27 is 3. 3 squared is 9. Right? How many people got 1/9? Raise your hand. Couple. Good. I see you. See the hands. Nice. I'm going to see if I can change this for a second. Okay, in the chat, what's the next answer? You may already have it. Go ahead, let me see who gets it first. What is the next answer? Let's see if I can get more people coming up here. Nice, I do this way. Ooh, and then he puts a question mark. Does that mean I count it? Is that your answer? Maybe he's right, maybe he isn't. Oh, then he removes the question mark. I like that, Aiden. Nice. Okay, and I think I'll just pop in here every once in a while in the video if I can remember. I got so many things going on here. Okay, so Aiden and Colin, are they right? Nice. We'll give you both credit for that one. Okay, so definitely this one is the cube root again of 64. 64 is a special number. The cube root of 64, it's not the square root of 64. The square root of 64 is 8. The cube root of 64 is 4. 4 times 4 is 16. 4 times 16 is 64. And then you square it. Yes, you're expected to be numerate. There would be no calculator versions if we're in school. That's why people are probably praying, please, let's not go back to, in school. Then Mr. Samuels have no calculator tests. But, you're this far in your mathematical careers, we should know some of that math. I don't know if I'll be able to tape this. I'm just going to end this, get this out of